It's your friendly math tutor, Miss C here, and today we are rationalizing the denominator. What does it mean to rationalize the denominator? Well, essentially, it means that we are removing any radical. So that would be any root bar from the denominator. So in this example, you're going to see that in the denominator, we have the square root of 5. When we rationalize the denominator, we would no longer have that root bar over the 5 in the denominator. And actually, there's a whole process for it that we're going to go over. We can also rationalize the denominator when we have denominators that look like this. This is a little more challenging because of the addition sign or the plus sign, but essentially we need to figure out how to get root 13 out of the denominator. And finally, we could rationalize the denominator when we have something that is not a square root. It could be a cubic root like this one. It could be a quartic root. It could be any type of root, but the bottom line is we don't leave radicals in the denominator. So let's look at how we do that. We have 3 divided by the square root of 5. So our goal is to remove the square root of 5 from the denominator. So to do that, I'm essentially going to try to get a perfect square underneath that root bar. So the way that we do that is we multiply the square root of 5 by itself. So we multiply the square root of 5 by the square root of 5. When we do that, we end up with a denominator that has the square root of 25, which we know the answer to. But I can't just do this to the denominator. I can't just multiply square root of 5 to the denominator because now I've changed the value of my fraction. So I also have to do it to the numerator. So essentially, we're creating an equivalent, or we're creating a fraction that has the same value because really what we're multiplying by is the square root of 5 divided by the square root of 5, which is 1. So a lot of math is about manipulating things to make them look a specific way without changing their value. And that's what we're doing when we're rationalizing the denominator. So let's go ahead and do that. So we have 3 times the square root of 5, which is just 3 times square root of 5. So we often write this with the coefficient next to the root bar instead of with the multiplication sign present. And then we have that over the square root of 25. So our next step is just to simplify so we don't have that radical in the denominator. By the way, I'm using the square root bar and radical simultaneously because they're the same thing. A radical is just any type of root, and then a square root is specifically a root where it's a number that's multiplied by itself. So okay, so we end up with 3 times the square root of 5 divided by 5. And this is our simplified answer. All right, let's do it again. We have 12 divided by the square root of 6. Our goal is to get the denominator so there is no radical or square root in this case. And the denominator, we do that by multiplying root 6 by itself. So like that, what we do to the denominator, we do to the numerator because we are making a fraction that has the same value. Remember, root 6 divided by root 6 is 1. All right, so that gives us 12 times the square root of 6 in the numerator, and root 6 times root 6 is root 36. When I simplify that, I get 12 times square root of 6 divided by 6. We're not quite done because we haven't simplified our fraction. So 12 divided by 6 equals 2 times root 6. So that's our simplified fraction. So I can't simplify what's inside of the root bar that's locked in there, but I can simplify the coefficient outside of it with what's in the denominator, which is what we just did. Let's take it up a notch. So here's what's interesting about this problem. I have root 24. What I know is there is a root trapped in there that's a perfect square. That means that part of this value will go away or live outside of the root bar when I simplify it. So there's 2 options here. I could do what I just did and get root 24 to the numerator and then simplify, or we can simplify the denominator so we're multiplying by a smaller root. I am going to do the last thing I just said. So I know that root 24 has root 4 as one of its factors times root 6 as one of its factors, right? So root 4 is the perfect square. So I know that I could rewrite this like this. if I were going to do this algebraically. And what I know is this is really equal to 2. So I could rewrite this as 8 divided by 2 times root 6. And then what I can do is I can come up here and say, well, the 2 can stay in the denominator, but the root 6 can't. So I'm just going to multiply by root 6 in the numerator and the denominator. And what I end up getting is 8 root 6 divided by 2 times root 36. Okay? Now we just need to simplify root 36. So I have 8 root 6 divided by 2 times 6. We're still not done. So now we have 8 root 6 divided by 12. So close. Now we just need to simplify 8 divided by 12. 4 goes into both of them. So if I divide 8 by 4, I get 2. If I divide 12 by 4, I get 3. So I end up with 2 root 6 over 3, and that's my simplified answer. If you're like, hey, Miss C, you could have simplified way back here, you are absolutely right. At this point, I could have said 8 divided by 2 is 4, and then worked it from here. Both ways are correct. It's up to you. All right, now we have another situation where we still have a coefficient right here, and we've got another problem where we've got root 20, which also has a perfect square in it. So let's go ahead and tackle that. And I'm going to do it a slightly different way. So root 20 has root 4 in it and root 5. So root 4 times root 5 is root 20. Root 4, like we just talked about, is a perfect square. So this becomes 40 divided by 2 times 2 times root 5. Okay, so that gives me 40 divided by 4 times root 5. Unlike the last problem, I'm going to go ahead and simplify this. 40 divided by 4 is 10, so I end up with 10 divided by root 5. Okay, now I'm going to go ahead and multiply root 5 by root 5. What I do to the denominator, I do to the numerator. So I end up with 10 root 5 in the numerator, and I end up with root 25 in the denominator. Okay, now root 25 is equal to 5, and now I get to simplify once again. 10 divided by 5 is 2, so I'm just dividing my coefficient by 5, so I get 2 times root 5, and that is our simplified problem. And that is all we have for today. Thank you for taking the time to rationalize a single denominator with me. So a one-term denominator or a monomial. The next video will have the problems when we have to simplify a denominator that is a binomial and contains a radical. All right, make sure to subscribe for more math videos. Till next time, remember, you've got this.